Both mics. All right, so if you're just coming in, you can follow these instructions up here. Navigate to the tinyurl.com r-davis-week-6. Doyle, it sound that weird?
That doesn't sound like you actually. It really doesn't sound like you.
Is there an echo in here?
So go to week 6, open up the Google Doc, the live script in separate tabs. And then right here in the Google Doc, just below these instructions, add something that you understood about the homeworks that you liked. And then below that, in the next section, add something that you didn't like about the homework or that was sort of a sticking point. I'm going to try to adjust the homeworks as we move through the course. And then once you've done that, skip down to the next page in that Google Doc, and there's an opening exercise for you to get plotting right away. So once you've added your points to the Google Doc and finished that exercise, put your green sticky note up and put your red sticky note up if you need somebody to come around and give you a hand.
Or if you don't have stickies, raise your hand.
Does it work now?
Where are you?
Did you give the lecture staff?
Oh, here, weeks.
Yeah.
Yeah, I think it's all. I know, it's not a big deal. Yeah.
Good. Oh, I'm glad. That's yeah, we could do nothing to that, but I think the last week is still open. Yeah, we actually.
All right, so I'm seeing people are liking the playing around with the different visual features that you can change with the plot. We're going to do some more of that today. That's great. Yeah, editing the code to sort of see what those changes are. I do that all the time. It's my go-to way of figuring out what code does is tinker with it. There's no harm, there's no cost to trying code. Dan. Working through. All right, can somebody expand on what they mean by sort of working through the code and rather than copy pasting? Just give me a sense of what that means. Like starting from scratch and writing your own code, or the part where we are rearranging lines of code, or you can add it to the Etherpad too. If you don't want to speak up, that's also okay. If you're just coming in, there's a set of instructions up here on the Etherpad, or sorry, on the Google Doc. Google Doc. Wes Anderson color palettes, they're awesome. Let me make this instruction explicit here. When you have finished your homework, completed the opening exercise, put your green sticky note up. Let's be explicit here. Your green laser kitty. Great. It was. Yeah, I believe that we saved it.
We did.
We did save it. Possibly in the data output folder. Does it sound right? Tell you what, I'm going to change the instruction. If you finish adding your pro and your con to the about the homework, put your green sticky note up. So if you're working on the plot now, put your green sticky note up so I can tell that we've moved on from that part. Okay. Okay. Everybody put the sticky notes down and keep working on the plot now. Seems like we've moved past that. We'll try to give a more of a variety maybe with the homework. It seems like the general idea is you all were getting the mechanics, but maybe some some additional optional questions or something like that would be good for those of you that want to work through some more. We'll discuss that and adjust as necessary.
And please work with folks around you too. It's very quiet.
You know,
You saved it as a CSV in your data folder. And so then you just import it as. Yeah, we wrote it to a CSV.
All right, take another couple minutes to try to work on this plot. Green sticky notes up when you're finished. Red sticky note up if you need a hand.
Yeah. You can do it up top too.
But still, you don't. You still have to use it.
Okay, Ryan. Do you mind going to my Dropbox and throwing the link up to the surveys_complete CSV file in the data output? And then throwing it up to Etherpad in case folks don't have it from data output generated.
Is that already on the WCD actually?
Oh, it might be.
Under resources. Let me look over.
Okay.
The survey is complete, right?
Yeah,
Yeah, it doesn't look like it's up there.
not up there.
It's all
Thanks for your ambassadorship.
I was like, I'm gonna take responsibility for this.
Good work. I'm seeing some green sticky notes and some not. So let's walk through this. Pull up our studio. First thing I'm going to do is copy that code over here and make this a bit bigger. Everybody see that okay? Okay, so we've just opened up our studio for the first time for this particular session. What's the first step that we need to do? Say it again.
Load library.
Exactly right. And so what library should we load? Let's load the tidyverse. Library tidyverse. Right? Before we can use any of the functions that are part of these packages, we use the library function to load those packages. So library tidyverse, going to run that. And we've got the little caret, so we're good. Okay. What's the next step? Load the data, right? So let me make this explicit here. First step is to load the packages that we need using the library function. Next step is to get the surveys complete data, right? If we were to run this line here, we're going to get an error suggesting that object surveys complete not found. So what function can we use to import data? Have we seen? Read CSV, right? And let's go ahead and call it, assign it to a variable. So surveys complete is assigned to be read underscore CSV. And I think we just decided, so I'm gonna try to use tab complete to help me out here. I thought I put it in my data output folder, so I'm gonna hit lowercase d and tab. There's my data output folder. And let's see what else is in there. It looks like surveys complete is the only thing in there. I can also confirm that by going over to this bottom right panel, files. And my data output, here's my surveys complete CSV file. So run that.
You have compete.
Oh, that is going to be a problem later. Thanks for watching that. Okay, so surveys complete, right? Not compete. And what's a good practice to get into anytime I import data? Look at it. Yeah, exactly. So I'm going to use the glimpse function, which is a lot like the str function in base R, but it plays nicely with tidyverse objects. So glimpse surveys complete. And this is going to show me the different column names and some more information about this particular data frame. The number of rows, right? The number of observations, the number of variables, the number of columns, and then all of those different column names. And let's see what happens with this plot before we change anything. So run that line. And here's the plot that we end up with. right? Which is, I think, the plot that we were making at the end of class last time, right? So we have taken, let me enter this up a little bit. Taking the survey's complete data and using the AES function call, we are mapping the weight column to the X position, right? So we're translating data to a visual feature. So we're using the AES function call and mapping the hindfoot length to the Y position. And then we're using the plus sign here at the end of the line to add our actual geometry, the actual points, right? So remember, ggplots, the function sets up the canvas, and then the geom functions are what add those features to the canvas. So that's what we get there. Oh, whoops. This is my comment here that should be here. Oops. Right. The code. I think if you didn't have the surveys _complete CSV file, we have a link to it now in the Google Doc, so you can go and download it and put it in your data _output folder so that you can follow along with us today. Okay. Question asks us to, how would we make a scatter plot of what was it, weight versus species ID, right? Okay, so I'm going to start with ggplot. It's a tidyverse function, so the first argument is, oh, but not complete. Oh, here we go. Here's an opportunity. I'm going to use the rm function to remove a variable from my environment. I'm going to get rid of surveys compete, so it's no longer messing with my tab complete. Surveys. So now surveys complete is the only thing left, right? So the data survey is complete. I'm still mapping data to a visual feature. So what's my X position going to be? It's weight versus species ID. Species ID, all right. And how do we spell it? Is it lowercase, uppercase, lowercase, species, like that? No.
Underscore and then lowercase.
Like that, right? Okay, great. And Y is going to be what? Weight. And then a plus sign, and we're going to add, because we're making a scatter plot, a genome point, right? I see a little X here indicating something's probably going to break. We'll figure out what that is. Looks like missing a parentheses here, right? The AES function gets a closed parenthesis, and then the ggplot also gets a closed parenthesis. Like that, right? Is that what everybody had that got a plot? Okay, is this a good way to visualize these data? Why not? We used a jargony term, I think, last class. Anybody remember? Ugly, ugly. All right. How about overplotted? Right, we've got all this data on top of itself, and it's hard to see what's actually underlying those patterns. So instead, we can make some changes to better visualize this. But that's how we got through the exercise that we just did, right? Okay, so pause there for a second. We're gonna jump right back in here. General stuff about today. I see that a lot of people are filing issues, which is great, and and a lot of people are filing like, you did a great job, your code works, and you know, I found no problems, which is great. And I want to emphasize what I emphasized last class, that filing an issue shouldn't feel like an issue, right? If you have positive, constructive feedback, that's also great. So get in the habit of filing those issues. It's a good part of your collaborative workflow, especially working with code. Oh, and I set up an office hours so Ryan leads the Davis R users group, and that's on Mondays in this space from 10 to 12, right? And people come here that with their R questions, they come here just to like work on R code. So if a question happens to come up, there's a bunch of people here that are able to help. So if you are having to, that's a great place to come generally with R questions, but also specifically for this class. So this space, Mondays 10 to 12, and that's on the Google Doc. And then I'm gonna be available Thursdays, also 10 to 12, just in my office. So same kind of thing. If you've got any questions and you want some more one-on-one time, we can work through that. And please, if those times don't work for you all for any given reason, email us. Let us know, and we'll find a time to meet with you and catch you up to speed. So, any questions about that?
And I just want to reiterate what Mike said. I really want to make sure that everybody is. You please feel free to email us if anything comes up, or if you feel like you're dropping behind, or just really not understanding stuff. And we don't want people to sort of drop off the map. I would like everybody to cross the same line at the end of the quarter, and that being that we all at least have this sort of core understanding of what we covered this quarter. Okay, so please don't hesitate. We'll figure it out. We'll find some time to talk with you and sit down and make sure that everybody is on the same page. Don't feel like it's an issue, a problem, that learning this stuff is tough, and it doesn't take much to sort of quickly fall into a loop of despair, having done this stuff before. Okay, so please take advantage of this and us while we're here. All right.
So I was going to, office hours. I was going to not go line by line through the homework. There's my repository is up there, and there's a link in the Google Doc. I got the sense from your all's feedback that maybe the mechanics of it, the specifics of it went okay. But if you have specific questions about that, come talk to one of the helpers, Brian, me, either during office hours, after class, what have you, and we'll work through it in a more detailed sort of way with you. But I think I got the sense from the Etherpad that we might be doing all right on that front, at least for this past week. Okay, so let's go back to this point here. And we said this isn't a great way to display the data because it's, but Jonah said ugly, right? And it is hard to see the data. Yeah? All right. So how might we display the distribution of the data, or of a vector of data, if we were thinking about just a single axis of data, like weight, right? Like how do we display the distribution of weight? What are some ways that we can think about to display a distribution? Okay, so mean and standard deviation are some good summary features, and maybe I'm not asking this well. Somebody else said something. Box plot. Let's go there. So let's try ggplot data equals surveys complete. AES x equals weight. Y. Oops. No, that's right. No, it's wrong. X equals species ID. Y equals weight. Fine. So if genome point makes us a scatter plot of points, what do we think makes us a box plot? Genome box. Fine, there it is. Genome box plot. Right, so now we've got these distributions, but they're represented by box and whisker plots, right?
Mike?
Yeah.
Somebody asked, how could I order those box plots so they went in like descending order or something? Is that something we can do?
Yeah, I think I'm sure that it is, because right now they're in alphabetical, right? You did.
Chris, how did we do it?
So for the x equals, you just write instead of species ID, reorder.
Gigi, walk me through it. Data equals.
Surveys complete. AES. Species x equals reorder.
Okay.
And then in parentheses, species ID, comma, dash weight.
Dash
minus
weight.
radius.
Got you. Okay. Nice.
And then everything else is the same. Y equals weight.
Y equals weight. Box plot. Like that?
Yep.
Ooh, nice. Nice.
One other thing you could do is, because they're factors, the cool thing is you can actually order these in any way you prefer. So we'll talk a little bit more about how to do that. You can literally list, in this case there's a ton, so this is actually probably the best way to do it, but you can actually just refactor these, re-level them in the order that you would like them to appear.
So specifically, if you wanted NL to appear anywhere in this list, you'd be able to adjust that.
Yep.
And if you want it to be ordered in increasing fashion, then you just do plus weight.
Just keep this weight here, right? I will add that in.
Did you update the line code?
Yes, thank you. That reorder function is taking the species ID and then adjusting the order of which those species are by either negative weight, right, which is another way to just sort of flip the vector on its head and go descending, or weight by itself for ascending. Nice.
Good question.
I don't know if I'm gonna ask you right now. My question was, how come it doesn't work to switch the X and Y axes?
Let's try. Specifically on a box plot, right?
Yeah, on a box plot. This data set's kind of weird, but I ran into an issue with this trying to plot my own data. Box plot just like wouldn't do it
Okay.
because of what was on.
Huh. So.
Yeah.
Like it. So are you getting that and
Yeah.
without creating the box plot? I don't know the answer to that. Does anybody else know? Is there a way to like do a horizontal box plot?
So
That's exactly how I would have approached that too.
Right. So typically, the Y is always going to be your numeric, in box plots at least, is always going to be your sort of response, right? So it's always going to be numeric typically. There are ways around it, but if you want a sideways box plot, so if you want exactly what we did, the easiest way is to use the exact same code you had above, right? The one before that was ascending by weight.
Ascending by, oh yeah, here.
Copy that down. And then at the end, after geom underscore box plot, do plus ward underscore flip.
Ooh. My. Nice. Cool.
You can use ward flip on almost any type of plot for the most part. It's a really quick and easy way to sort of flip your axes without having to flip your axes in a sense.
Also especially nice if like you have all the species names listed out and they're all on an x-axis and they all breed together, right? Because they're all horizontal and they just overlap. You flip it like this, and suddenly you can have the full names listed out, and they'll just be stacked on top of one another. See what I mean? It's very nice in that.
Is it next week or the week after? We're going to do some more fancy TV plot stuff for visualization.
We get to some of it today, but I think you got a nice suite of things that we'll talk about next week, right? Yeah. Coordinate underscore flip, right? Cool. All right, so let's go back to how we had it. Oops. So this is the box plot that we had created before that's not in ascending order, and it's without the axes flipped. Species ID, y equals weight. This is what we had before. Let's put some points underneath of it. As even this plot, we're obscuring some of the data, right? We've summarized it into these box plots, demonstrating the median and the quartile. Yeah.
Do you want to update?
Yes. Yeah. Please keep on me about that. So let's add the data itself back in, right? This is great that we've got the summarization of data, but if we can demonstrate, if we can show all of the data, that's often better. It's often best not to hide the data itself. Back in. It's geom box plot. And I'm going to use, we could have used geom point, right, to add those points right back in. And we saw sort of what that looks like. They're all in a line. It's sort of hard to see. So I'm going to instead use geom jitter. Just going to add a little bit of random noise to each of those points in the x direction to sort of offset them from each other. And we've seen this before. So yeah, we've seen this before of setting the transparency of those points. There's still going to be a lot of points, so we'll make them a little bit more transparent. And then we're going to color them also. Okay, I didn't use an aesthetic, an AES function call for these, right? So I'm just going to be setting every single point to be these values, a transparency value, an alpha value of 0.3, and a color tomato. Or tomato. So still a bunch of points, right? But now they're at least separated a little bit. You can sort of see what the density of those points are. But we've also lost the box plots behind it. So let's fix that. Anybody have any intuition on how we should go about fixing that if the points are coming on top of the box plots? That sounds good. Geom jitter, alpha equals 0.3, color equals tomato. Box plot. Right? So what this is showing is that you really can think of this as an iterative process, right? As you build these layers, one on top of the other, they are actually being added to that canvas in that order that you're specifying. Okay. Good. All green sticky notes down. Box plots are great because they sort of show us this distribution of data, but they hide the shape of the data, right? If there were a distribution that were bimodal with two different humps, we wouldn't be able to see that with the box plot. It's ultimately still a pretty coarse summary of data. So there's a geometry called violin that will actually show you the distribution of the data. So modify this code here. Instead of putting a box plot geometry, add a violin geometry and see what that looks like. Green sticky notes up when you're done. Take 2 minutes and do that.
You okay, my code?
Yes. And I will add this here. Geom box plot adds box plot shape of the data by adding a violin geometry.
More visible, right?
This isn't the district. So moving them left or right doesn't mean anything, right? It's not like it means anything. It just spaces out.
Yeah.
Your red sticky note. Okay, so I'm seeing mostly green sticky notes. So ggplot data equals surveys complete. Aesthetic X is still going to be the species ID. Y is going to be the weight. Let's see what it looks like in isolation. So geom underscore, what do we have before? Box plot added the box plot. Geom underscore violin is going to add a violin plot, right? And those are pretty hard to see, so we're going to make an adjustment here. But you can see that they sort of show you the shape of the distributions. We've got these really long tails, right? So let's modify the scale of the weight axis. We saw this in the homework last week where we modified the scale of the y-axis to put on the log scale. So I'm going to... So we're just going to continue down on this particular challenge. So represent weight on the log 10 scale. We saw scale underscore x underscore log 10, which modified that scale on the homework in the Gapminder data. Try using the scale underscore y underscore log 10 function as a new layer to modify the scale on the y-axis here. So all green sticky notes down, but put it back up when you're finished. Red sticky note up when you need a hand.
Feel free to talk to your neighbor.
That's good. Yes. All right. That's your arm.
It's turns out our not. Cool.
Oh. Yeah. I think that should work too, right? I mean, just look the same. No.
But well, just if you're modifying code to like to keep just the GG plots, because then you can't modify the fantastic log as opposed to like we're gonna add things to it, right? If you're just gonna be doing
Yeah, that's a good point. If you're modifying the original, the data is getting passed over all of the aesthetics and the entire GG plot versus.
yeah, because you say like when you first are running it, just to keep the GG plot itself like as bare bones as possible if you want to do things to it.
That's certainly one approach, right? To sort of keep all of the modifications elsewhere. Okay, let's see how this works. y-axis to be on the log 10 scale. So I'm going to do my ggplot. My ln, and then I'm going to modify the y-axis scale like that. And it collapsed the weight down to the log 10 scale, right? And so now you can get a better sense of what the violin plot is doing, right? If you imagine each of these halves of the violin is a density distribution on its side, and then it doubles it over, right? So you can see that this particular species, PF, has a few different modes in it. Yeah.
So there's a problem with that. If you put the jitter plot back on that, you'll see why that's doing that.
Let's see what happens. So here.
So it's the weight is the scale of the weight is less of a resolution. We're at a finer resolution at the 10 at lower down, right?
So you're only getting like the 10th decimal point. Or something.
Oh.
Right.
Oh, so that's like that's how you're getting these bands here. Is that what you're saying?
Right.
Oh, interesting. Yeah. Huh. Good to know.
So that could be a problem as far as analyzing.
Could be a problem. Yeah. Okay. Careful adding points back in. You have. Oops.
Chris, yeah, your question?
Yeah, I was just going to ask, what if you want to scale it on a some different way, like a log base 2 or something? That function doesn't exist.
Doesn't exist.
Yeah,
So,
it's result.
huh? So you could modify it directly here, right? And call the log function on that. I think somebody who was it that tried that in the front? Yeah, you tried that and that ended up working, right?
So
So
you just write the full weight is like log 2 or something.
yeah. So let's try it. ggplot. X equals species ID, Y equals log of weight base 2. Right? So now it's 2, 4. Does that make sense? Doesn't seem to. Yeah.
One thing you don't get with doing this sort of method is that it doesn't scale your axes, whereas adding a log scale at the end, ggplot is smart and it figures out like, oh, you'll want to scale your axes too. That's why we had the axes before. It's like 10, 100. You know, it knew to do that. So that can be maybe
It's pretty easy to change your axes labeling to whatever you want and to scale it to whatever you want. But generally, if you're going to transform your data and you're not going to use the base, you know, like the scale, log, whatever, I would do it beforehand. So like in your actual data frame, make a this column is log 2 of whatever, and then you plot that, and then it saves code and it's a little more transparent. But the other thing is then it allows you can play with your axes to, you know, if you're going to color something, to get it to how you want it to look. But yeah, you can pretty much put whatever you want inside of that y equals or x equals that you with like any function or pretty much anything you want, you can do it, and it will plot it on the fly for you. But like Michael was saying, then your axes can kind of look funky, and you have to kind of do some additional cleanup to make it look nice.
Although it is plotting the right thing,
Correct.
though, right? It's
Either
just that
way
the
it'll work, yeah.
the axis isn't scaled as. It's not scaling the axis, it transported the data itself and then plotted it still on a linear axis. That makes sense. Okay. All right. Let's. All right, let's plot the species abundance per year. Counts per year for each species, and we've seen those data don't exist in the data frame that we have right now, right? So we need to do a transformation of those data. We need to do a summary of these data. And so let's call it yearly counts. And I'm going to assign that, and we're going to use our dplyr verb. So for each species year combination, we want to count all of the observations. For each species year combination, counts the number of observations. And we saw how to do this with the tally function by passing in surveys complete. I'm going to use the pipe operator to pass this as the first argument to the next function. And I don't know if you have seen this yet, right? So percent greater than sign percent, you can do a shortcut shift command M. We'll paste a pipe in, right? Let's group by year and species ID. So that's how we split this data frame. We're using the split, apply, combine technique, right? So we start with the surveys complete. We're going to split it into these sort of tinier subsets of data frames where each one is a different species year combination. And we'll pipe that to the tally function to do our counting. Open up our console. And let's see what that looks like. Yearly counts. So now we have this summarized data frame, right? Before we had 18,000 or so observations. Now we've collapsed that into a 292 observation data frame where there's each row represents a different year species combination, and then the N column is the number of observations for each of those splits. So now we can use that to plot. So let's say the data are the yearly counts. And let's look at this sort of time series. So we're going to map the year data from this summarized data frame to the X position, and then the counts to the Y. And let's use a line plot, which we haven't seen yet, but as you all might imagine, it would look something like this, right? Geom line. Oops. So one problem with this is that it's connecting all of those points, right? It doesn't. We haven't said that we should have a sort of separate line for each species, and so we can do that using the group aesthetic. Again, X equals year, Y equals N. Make our geom line. Now the grouping is another kind of aesthetic because we want to take the data from this yearly counts and use the species ID data and then make a line for each one of those groups. We're going to say group is equal to, or sorry, group equals species ID. Oh, we have a different line for each species. It's sort of like plotting different, like in Excel, there's series, right? And so we're going to take a break for 5 minutes. And when we come back, we'll clean this up and start playing with some more of the visual features that we can tinker. So come back at 3:07, and we'll carry on from there.
So, yeah.
I'm barely touching, but I guess kind of like sleep. Yeah. But also, how much money should I get? Sorry.
Well, I also have 50 pages of reading. So, kind of reviewing what I'm working on.
But you're the class president for the special needs. Oh my God! I like doing this, like, every time.
Oh, try in underscore status, which is like okay, so asking how many include by.
Yeah. So that's just the end levels. Series would be
Otherwise, all right, let's come back up front. So it might be clearer to see what this group is doing if we use color instead. So let me show you what that looks like. Let's use color aesthetic instead of group. You plot. Data is yearly counts. Aesthetic X is year, Y is N. Geom line. And we've seen this before, right? Using the color aesthetic to take the species ID data and map it to that visual feature. Color is species ID. So when we run that, let's see what's going on. Yearly count, did I spell it wrong? Yearly count. Yearly counts, okay. So this, I get this error all the time, object whatever not found. And the first thing I think is, okay, did I make a spelling error, right? Because this is the actual object that R is looking for, but I thought that it was called something else. So I feel like that's one of the main errors in R comes when you and R don't agree on what your objects or your data look like, right? So that's why it's always good to look at the data when you import it. And well, maybe you all spell better than I do, but I get that error a lot. Okay, so we've seen this color aesthetic, right? Where each species ID now has its own color on that plot. So group was doing something similar, it just wasn't coloring them, right? It grouped all of those observations from each species and created a separate line for each of those groups, but it just didn't color those lines. So it's sort of color is grouping automatically. Okay, something that I definitely want to show you is faceting. This is how we can create some multi-panel plots. And so the way this works, the syntax is a little bit different. Yearly counts with S, X is year, Y is N, line. Now instead of creating a separate line for each species, I'm going to create a separate sub-panel for each species. And the way that works is like this. It's a whole nother layer. And I use the facets underscore wrap function. Then within this, I use what's called the formula syntax. So it's a tilde, which is a shift, and then the button just under your escape. Tilde. And then on the right side of the tilde, I'm going to put the thing that I am faceting by, the factor that I'm faceting by. Give you a sense of what this looks like. Now I have a separate little sub-panel for each of the different species. They're labeled automatically. Sub-panels on a single plot. Use a factor as your data to facet on.
What if I just wanted to look at Or my favorite species.
4 of your favorite species? So my first instinct would be to subset those data before you fed it to ggplot, right? So subset, and in that case, I'd be using a filter. Filter is equal to, or, and saying, okay, I just want to pull out these particular species. Is there a better way?
No, I think that would work.
That might work? Okay, let's do it then.
You would use like a list to that list and species ID.
Oh, I see. I got you. Okay. Let's just look at our favorite 4 species. So here, I would take yearly counts. I would pipe that to a filter, and I would say species ID is equal to, let's say DM, or species ID is equal to, or I'm using this bar to say the OR function, or species ID is equal to OT. Species ID is equal to R. Here's something cool if you're working with dplyr and you've sort of modified this data frame, you can pipe that directly to the ggplot. ggplot, right? Because the very first argument in ggplot is the data. So that's what's coming from this filtering operation. And you know what? Best practice, I'm going to make sure this actually works. How I think it does? Okay, at least it runs, right? So let's start there. And it looks like those are just the species IDs that I was filtering by. ggplot static x equals year, y equals n. Now this is where I sort of am mixing the pipes to input the data, and the plus sign is where I'm adding the different layers to the ggplots. And we'll do the same thing: geom line plus facet wrap. Hopefully that just shows those particular ones. That's how I would do it. I'm sure there's bunches of ways that you could. All right, let's split this apart by sex, right? So there's, in this survey's complete data frame, there's 2 different sexes, male and female, for each of these species. And so let's put a plot for each of them. So we're going to make a new object called yearly sex counts. Pipe that to a group by. This time I'm going to group by year, species, ID, and sex. Pipe that to a tally again. Now in this yearly sex counts data frame, now I've got an extra column here. So where each row represents different year, species ID, sex combinations, and then the abundance for the observation type. So making our ggplot here, data equals yearly sex counts. Static x is going to be year still, y is still going to be n. And let's have a different color for each sex. And we're going to facet wrap just like we did before with a different subpanel for each species. Let's see what that looks like. Now we've got all of these redrawing. Here we go. Different subpanel for each species, and now 2 separate lines because we've used the color aesthetic on the sex variable. Okay, there's lots of different ways that you can modify specific parts of the ggplot. You can make your font bigger, you can make your font italicized, you can add text places, you can change the labels, all kinds of things that you can do. I'm going to talk generally about themes, but essentially, if you want to make a change to a ggplot to make it more visually pleasing to you, it's possible. So yes.
What's the best resource to determine, if we imagine, oh, this is definitely possible.
Yeah.
Where do we then go to figure out what to write down?
That is a great question. So I would say, two things I can show you here. In RStudio, up here under the help file, under cheat sheets, there's a bunch of really great resources right here, right at your disposal. I think they're all PDFs, but they're beautiful and they're intuitively designed. And there's one for dplyr, there's one for ggplot, there's one for our markdown, which we will start learning about later on. Yeah, go ahead.
There's also, I don't know, this is like a little bit cheating, but there's a add-in that you can download for RStudio that lets you plot your plot, and then you just wrap it in this add-in, and then it's this other window that pops up, and then you can toggle, I want to change the font of the x-axis. I want my x limits to be this much. And you can change it all with out code with toggling.
That's real cool.
It's a little cheating, but then it inserts the code into your ggplot, and you can look at how the code is written, so that in the future you could write out the code yourself instead of having this add-in. But that's something useful for learning.
What's that called?
What is that called?
If you go up in RStudio, there's a little right where it says add-ins.
Sorry, I don't see it. Down.
Right.
Down. Right.
Up.
Oh, I see it.
So yeah, you have quite a few add-ins, but you guys will probably all have none, or maybe some if you already downloaded some. But it's something that you can just Google. I think it's called GG Theme Assist.
Oh, it's right there.
How about we walk
Marginal
through this? I do have this, and we were going to do some of this from the visualization lesson in a bit.
That sounds.
There's good things and bad things about this. I don't want to jump into it quite yet. I would also say it's awesome and it's great, but again, it gets away from the when you're clicking buttons and you don't necessarily know what's happening. There are things that can break. I don't know if I've found it to be kind of buggy sometimes with certain thoughts.
I only learned about it a month ago, so I kind of knew how to create graphs. I only use it when I'm really struggling.
So I pasted into the Google Docs the actual ggplot help page, which is great. And can you go over to the ggplot or the?
Is it in the Google Doc you said?
Doc, yeah.
Above this, below this?
Down at the bottom.
Bottom.
There you go.
Okay.
And I just want to walk through really quick, take a look at this, because they've done, and they keep building this out, which is what's really cool, is they keep updating this with more and more examples. You'll see on the right, they have all the different sort of potentially layers and stats and different things you can add. But if you click maybe down, I don't know, find somewhere, any of those links on the left, actually, if any of the things there, if you click on any of those, maybe find, and then scroll down, you'll see they have, not only do they sort of define all the help and what each piece is, but then they give you code and examples of all these different things. That one's not a great one, but there are many that they have actually the actual plots in there. So you go like a geom something, contour.
Also in the add-in, you can't do anything. All you can edit your text and your axes and your title, the title of your axes, but you can't edit your data or the colors or so you have to. You can't just rely on that.
We'll definitely show that because it's still pretty cool. I don't want to discourage folks, but anyway, the ggplot 2 help page is great, and they have all the code here. And honestly, Google is also your friend. If you pretty much want to do anything in ggplot, you just Google how do I change blah 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 in ggplot 2. You're probably your top 3 hits are gonna give the code exactly how to do that. So ggplot is immense in the amount that it can do, and it's also immense in the trying to remember all the pieces that it requires. So don't expect that you memorize or know all this stuff. We pretty much I look it up all the time. How do I rotate my axes labels or something? I'll just look it up.
Sound good? Can somebody in that Google Doc also add the help cheat sheets? Just that you can point there too. This is, how does this go away? There it goes. Okay. Okay. Right. So generally, you can modify the sort of overall look of a plot using themes. Theta is yearly counts. This is the same plot as above. If I'm going to add a theme underscore BW for black and white, and it will change the overall look of this plot. So some of the gray background of the plot is gone. There's other themes too. You can have themes that like make your plot look like it's from the Wall Street Journal. You can have themes that take away, that strip these down even more, right? Where there's none of that background grid, and this gray bars are not filled in. So yeah, themes are a good way to start if you're looking to sort of modify everything at once. You can create custom themes that represent the modifications that you make also, and we won't go into that today, but that is possible. Yeah, Ryan, I was gonna show how to save a plot and then turn it over to you rather than sort of go through all of the different possible customizations. How does that feel?
Sure.
Yeah? Okay.
We're good. So whatever it's fine.
Okay. Okay. So final thing, and then we'll do a challenge. How to save a plot. The ggplot is a handy function for saving called ggsave. And so this takes the output from a ggplot and then saves it as a PDF file or as a PNG file, something like that. Something that's portable that you can send just that particular figure to a collaborator, or put on a website, or put in a paper, that sort of thing. And the way this works, by default, ggsave will store in a file the last plot that you created. By default, ggsave, and first argument is the file name itself. So the file name, and I'm just going to make sure that we have a figures folder here. Figures, right? So I'm going to say, in quotes, figures, my plot, PDF, and that should, oops. So over here now in files, in my figures, now I've got this myplot.pdf. And so you can modify, how big the figures are in inches, and you can change the file output type, whether it's a PDF or a PNG or what have you. It came up over here. So now this plot is available. But what I'd recommend is saving your ggplot as an object. So let's create that plot from before. And we'll call it something. We'll call it my plot is a ggplot of yearly sex counts X is year, Y is N. And we'll go back to that plot where we colored each species. This is what my plot looks like. And remember, now if I want to, it's saved as this object, my plot. If I want to actually visualize the plot within RStudio, I run the name of that plot, and I get back this plot here. And now if I want to save that plot, file name, and what is it? It's abundance year. The plot is the argument for my plot, just like that. Now when I run this, it should save my plot where I've specified figures, abundance by year by species. So I can click that. And it comes up here.
So it just sort of defaults to a certain size.
Yeah, and I don't know what that's based on necessarily, the default size, but you can adjust the size, right? So within this GG save, if I hit a comma and a tab, you can change the the width and the height of the plot. So for instance, width is the plot size, it's being created in inches, or oh yeah, even in centimeters or millimeters if you specify the units argument also. So you can adjust all of that.
And you can specify, I don't know if you see the DPI, dots per inch, basically. You can specify, like, if you want to make a publication, available, a publication level figure. Often they want 300 DPI or greater. So you could specify your width and height, units, cents, inches, or millimeter, whatever it is, and then DPI 300 or 600 or whatever it is. I think it sizes it based on the window, your window in RStudio by default.
Any questions about what we've gone over so far? All right, let's do a 5-minute challenge, and then we'll turn it over to talk about some data imports. Okay, you can use what you just learned to create a plot that depicts how the average weight of each species changes through the years. So we created a plot that showed how the number of observations of each species changed through the years. This is asking you to calculate a plot, or create a plot rather, to show how the average weight of species changes through the years. And then save it to a new file in your figures directory. Green sticky note up when you're finished. Red sticky note up if you need help.
Work with partner.
Work with partner. Yes. Yes. Done.
Right. Well, you're gonna have to measure these data frames because you're only gonna have one and three for each year. Which is gonna decrease the math. Go back to the original surveys.
showing you.
What we were plan versus reality is now like 2 weeks past. You know, what we were planning. But it's everybody's. Yeah, it's funny. We're on the side.
So then you want to group them, right?
By 2 days.
Look at
Hour
the
rounds
groups by BCC.
But there's an hour. I mean, that's one of the models.
Okay, so I've copied over that to the RStudio window, so I'm just going to cover that up. And there's a couple of hints up here now too. So create a plot depicting the change in average weight for each species through time, and save that plot. Here's a couple of hints.
But also, which I talked to Ted about the last year, like reporting the way through class. Part of it. And so he's discounted that somehow. That's great. But the reality is, honestly, like if you're teaching each person, so going forward, and then I honestly think that helps. In the model where you like you want to make it work, you want to make it do that. So yeah. And you can give a reality something like but if you did make it like only where amended required all the departments every fall.
Alright. So we grouped by species here, right? Each of that species here. At least that's what I did. I did select and then I have 3 columns. And now I'm gonna summarize.
I hesitate to so that's kind of
And I can just underline to the yeah. Okay.
Yeah.
Yeah, it's really average.
What's the full festival again? And we're supposed to plot it, right?
Yeah. We're gonna plot depicting the change in average weight.
Yeah.
Remember, be kind to yourselves. If you feel like you're just spinning your wheels, ask for help.
Yeah. So like if I do that,
I just looked at week 4 homework, I was like, so this works out well.
Hang on.
So one thing.
Nice.
I know we went over. No, I think
Yeah, that's what I think about is that you take the length vector, but it does not operate across every element of the vector, and it keeps the same length. So it can't be the same observation.
So summarize that here.
Not necessarily, the sublines takes a whole vector of values and right? So the mean function has numbers.
So how would you
Yeah.
the plot?
Oh,
So the
Oh, never mind. So this is only work. I just saw it.
Yeah, great.
So this one, this one works.
No green sticky notes. We'll keep going.
So why don't we start in the front? Yeah. Oh, so what kind of plot would you say? Oh, just like extension. So
I just didn't take it. But I do have a sense of which one I use.
Okay. That's awesome.
Great. So you should save it.
That's my bad. For some reason.
You should save it. Yeah, save your figure folder.
Actually, you just keep that. You just keep it.
Well, what do you have? What's the name of the song?
If you finish two other individual features you can play with, change the line width, or change the point size, or change the theme. An X label or a Y label that's different than what's there.
You should change the X. Is that what?
Yeah, if you're
Secret challenge.
yeah, secret challenge.
Wait, change what?
The X and Y axis labels.
this would be.
So you can see it was already here.
And also,
This gives you the summarize, gives you this.
Like, for each species, summarize
And
this.
so-
And there's, so this is like, mean race, 4 species. For each species. And then you say that's the mean that basically.
So what happens is
Oh, you
And then you're saying,
Okay.
so what you're So sometimes the business is saying it's clear stuff over the groups, it's just not, right? So here, first, we're gonna.
I feel like I got these. Okay, yeah.
That particular get out is this is a unique of years
I'm seeing a lot of green sticky notes, so let's walk through this. Okay, so if we want a mean value per species and per year, when I hear per, I'm thinking, okay, I need to be grouping by those values, right? That group by, summarize combination that we use when we're doing the split, apply, combine, sort of technique for summarizing data. And so here I've got started, and this is in the live code. So I've taken the original survey's complete data frame because I want it a mean value of weight per species per year. I'm going to group by species ID and year. I will pipe that to the summarize function. Remember, the summarize function takes a vector of values and collapses it into a single one, right? So let's make a new column. I'm going to call it mean weight. And what do I put here in order to get the mean weight of each species year combination?
The mean of the weight.
Right, I call the summarizing function mean, and then call it on the column that I'm interested in summarizing. Right, so we've talked about the difference between mutate and summarize. Mutate is maintaining the length of a vector. You're doing an operation to every single element of a vector. And then summarize takes that whole vector and it collapses it to a single value. So summarize is going to totally reshape the data frame that you're working with into a sort of summary statistic of some kind that you define. So they both require that you give it a new name for a new column, but summarize is going to be applying a function that shrinks the data frame, and mutate can maintain the same size of the data frame. So summarize mean weight is equal to the mean weight. I think, oh, and let's assign something. Mean weight surveys is assigned to be that operation. Now, if I look at this object, now each row represents the different combinations of the variables I'm grouping by. So different combinations of species ID and year. And then that final column is what I called it, mean underscore weight, representing the mean of the different weight observations in each of those separate groups, in each of those species ID year groups. So that's the dplyr part. Now let's plot it using ggplot. Data equals, this time I'm going to use the summarized data frame. My x variable is going to be year because I'm doing this across time, right? What's my y variable going to be? And then underscore WGT, right? And that's specific to my code, right? Because this is what I call that particular new column. So you could have called your new column bookshelves, and then bookshelves would have to be down here in Y, right? Okay, what else did we say we had to do? Average weight for each species through time. And so let's, because we want the plot to represent these different species also, let's go ahead and add our line and color each line by the species ID. This is what that plot should look like. Something like that. And even better, I'm going to say mean weight figure is assigned to be that ggplot, right? So now later I can call mean weight figure. And if I clear all of these for a second, did that by going up to this this broom here in the plot panel, clearing away all the old figures so I can make sure that this is generating the figure that I expect. And then I can use the ggsave function with the file name figures and mean weight figure.pdf. And the plot is the object that I just created. So that seemed to have saved. Save that file. And we can see the mean weight figure is right here. And it shows up like that, as its own file that I could email to somebody, drop in a document, what have you. Does that make sense? Did anybody make any additional modifications that are cool that we should know about, that we can like throw up on the Google Doc as something somebody else should look at?
I tried changing the size to 3 to make the lines thicker.
And where did you put that?
I put that in geom line.
Up in here, in geom line, and where within geom line?
Outside of
Outside the aesthetic, yeah, because I'm not changing the lines based on anything in the data, right? So, and what's the argument?
size equals 3.
Size equals 3, like that. Now, when I look at this figure, the lines are real thick, right? Anything else? Faceted by species. Okay, that's help is fine. And how did you do that? Facet grid. Okay. Cool. Okay. So which should I try first? Tilde first, and then species ID. Yes. Okay. Oh, right. And this is my figure. So that's how it's faceted that way, right? And so now you're saying instead, notice this facet, or the species ID is on the right side of the facet here. Now I'll put it on the left side like that.
Yeah, you have to
like
For some
this.
reason that way, I don't know. Period is just like all data, but I don't know why it works one way and not the
Huh.
other.
Oh, right. Sorry. Save it.
The lines are still pretty fast.
Oh, yeah. Right. That's. So we could get rid of this here, right?
One thing you can do, by the way, so why don't you get rid of the size equals 3.
Okay. Tell you what, I'm gonna
Or
copy this. Here we go.
And then save yourself some typing after you get rid of that. Why don't you wrap the entire, so at the very beginning, wrap the entire thing in parentheses. So the beginning of your object.
Okay.
Mean weight figure, put an opening parentheses. At the very end, put a close parentheses. Yep. What that does is it actually does both. It will sort of print your plot and save your plot all at the same. So it's anything you wrap in parentheses, R is going to interpret as sort of like I'm going to show this in my window, in the console or the plot window, whatever it is. So all at once.
Do you have to have it saved as an object to do that, or can you put?
Nope, that'll work on any code you run that is. It's just going to be particularly when you're saving an object because the object won't show up unless you use print or something like that, or run it.
Show up, but.
I have about 5 minutes and I want to introduce that lesson.
Yeah, go for it.
Sorry.
No, you're good.
We're going to change gears really quick. We're not going to go through the lesson really quickly, I promise, because we have a whole lesson set out. But I do want, so what I think we're going to get a lot more practice with ggplot. So if you're excited by some of this stuff, awesome. It's really fun. The more you start playing around with this, you can make all kinds of really cool plots. And we're going to do more of this. One of the things that I do want to spend some time showing you is like when you have data and you want to save it out in different formats and read it in different formats, how might you do that? And why would you use certain file types? So we have a lesson. And so I think this week, instead of going over this in class, actually this might be a good chance to essentially try something where you all work on something out of class. So you're going to work through the lecture out of class. And the assignment that Mike has written up, will post up, basically mirrors this lecture that I'm going to show you. So under the course materials, so your assignment is to work through data import and export. And I'm going to quickly show you a few highlights from this really quick, but I'd like everybody to work through this entire bit. It's not that long. It shouldn't take too long. But the assignment will directly basically pull from here for things for you to do. So green stickies, if you're up on this data import export, hopefully, okay. And I'm going to show all the code here so that it'll make it easier for us to figure out what we've got. And so one of the things that we have done is that we are pulling some of the data that we've already used, but if you don't have it, it's linked below somewhere. Oh, here it is, the species data. It's at this link. So if you want this data, you can quickly download it as a CSV, okay? But the main thing I want to talk through is there are different ways to read data in, right? So there's read.csv, there's read_CSV, and those things relate to the package. So remember, the tidyverse has all the underscore functions, whereas the base functions in R are the read dot or write dot. And there are a lot of different options within our studio or within these that allow you to change how you read something in. And so this lesson will walk you through some of those options. And so if I open, let's look at in our studio here. So let's just go up here. So I'm just going to type in read.csv. And notice all these other options, read dot, and actually if I take let me take the C off. notice all these options, read.csv2. This will be important. Notice the separator here is a semicolon. So in other parts of the world, Europe in particular, often they use this semicolon and they actually use a comma for decimals, whereas we use a decimal point and commas to separate things. The nice thing is there's a function already built in to deal with this sort of discrepancy between the way things are written. Okay, so you can, depending on your file type, you can switch this up. The other thing is you'll notice header. So there's all these other arguments, right? These are the main ones. There's a few additional ones. Header is a really important one because maybe your data comes in and it doesn't actually have a header, column names in it. And you want to read in that first row of data, you would put header equals false. Or you can play around with that. Or alternatively, maybe you have, let's go down to read table. So you see, oh, there's a ton of options here. The read.table is the most sort of flexible and it has a whole ton of options here. One of them, skip equals 0, and skip will also work with read CSV, I believe. If you had, say, data often comes in a CSV and there's like just a bunch of white lines at the top or some weird header that somebody's typed in, and you want to skip that and just go to your data, you can use skip to skip a number of lines, however many that requires. So there's a lot of functions in here, functionality. So that's the read dot. And similarly, if we go to write dot, there's also a bunch of options, right? So you can write out, same thing, CSV, CSV2, which would be that sort of semicolon-based CSV. Write.table allows you to use whatever you want to separate your data. Now I'd like to scroll, if I scroll down this, I've had the tidyverse packages loaded, and you can see there's write underscore, and there's a bunch of options here. It actually has write Excel CSV, or write lines, or RDS, which I'll talk about in just a sec. And then TSV, which is tab delimited, which is actually really handy for working with oftentimes genomic data. It needs to be tab delimited. So anyway, there's a lot of options. Okay, so that's the point. One quick thing that is pretty cool at the bottom here. So it goes through a bunch of these things. You can read directly from a website with a link, etc. Using save and load. So I do want to cover this really quickly. RDA files are .rda is a .rdata file. It's a compressed type file. So it will take, say, a 3 megabyte CSV and save it as an rdata file. It'll be just maybe 300 bytes. So it's very small. It's very compressed. The nice thing is it keeps all the stuff that you've done. Maybe you've made some things factors. You've made the dates how you want them. It keeps all that information. So when you load it back into R, you don't have to run any code to format your data how you want it. It's already exactly how it is after you saved it out. Okay? The main difference between .rda and .rds files is that when you save an RDA file, you can essentially save all the stuff in your environment. So if we look in our RStudio environment over here, see we have this whole list of things in here. If I were to type save, I could then basically list everything that is in my environment and then give it a file name, you know, like all my stuff .rda. It would save that all as one big file, and then I would use load, and all that stuff would come back in exactly how it is right now, which is really nice when you're doing a lot of different stuff, okay? The downside is if you're saving everything out, maybe you don't remember which version was correct or whatnot. So in some senses, it's actually nice to save one thing at a time, unless you really have a good sense of all the stuff you're saving is exactly how you want it, right? The RDS file allows you to save, it's a one-to-one. It will only save one thing. The nice thing is when you load it back in, you can name it whatever you want. So in this case, notice, and in the lesson you'll see, each of these is named, you know, mean underscore weight figure. So if I save these out as RDA and I load them back in, they will have this exact same name in my environment. I cannot rename them. I could rename them after I bring them in, but when I load them, they come in just like this. RDS allows me to name them if I want to name, remember it's one-to-one, so I can only do one at a time, but if I want to name this data, I can do that when I bring it in right off the bat. Okay, so that's it. So work through that, this lesson, this data import export, and then the assignment Mike has just pushed up to the ENTS discussion board. Basically mirrors this, and yeah, thank you all. Sorry we ran a minute over here, but good job. Appreciate it. Hopefully we're having fun. Oh, please visit the surveys and give us some feedback about how this class went, pluses and minuses. That's really handy. Okay, it's up at the top here. There you go. Thank you.
It's